Now what if we want to turn the problem around? What if we're given two vectors, vector x and vector y, of the same length, and we now want to place a mirror in such a way that vector x mirrors into vector y. Okay, so we somehow want to determine a subspace such that x mirrors into y. There. Well, drawing it might be easy, but what is it that we really need? Well, to position the mirror, what we need is a joystick. And we need to position that joystick in such a way that the mirror is placed in just the right place. What do we know about that joystick? Well, we would like for it to be of length 1, just because it's convenient. And we know that it has to be the vector perpendicular to all vectors in this subspace. Well, notice that if you draw a line between the end of vector y and the end of vector x, then the way mirrors work, this is supposed to be perpendicular. So if we can figure out this vector right here, then we know at least the direction of our vector u. Let's call that vector v. And what do we know? We know that v plus y gives us x, because the net effect of going here first and then going there is the vector x. And therefore we can see that v is just equal to the vector x minus the vector y. Alright? So v is equal to x minus y. And that gives us the direction of the joystick. But now we want to make it so that the length of that joystick is equal to 1. The length of vector u is equal to 1. And therefore we can choose our vector u to be equal to the vector v divided by its length. And now we have a systematic way of determining the vector that defines the subspace such that the subspace mirrors vector x into vector y.